Hello everyone, we are back onto the ZigZag task, and this time it's on that side. It's task number 10. Let's have a look at it together. Okay, this question modifies the skeleton program to introduce a storm weather event. Destroys all the ants and pheromones in any cell, including the queen. Only one storm at a time. A storm lasts for 3 stages. If there's not a storm already, every stage, every tick of the simulation has 3/4 chance of happening. Can happen anywhere, including the nest, but it does not destroy the nest. It will destroy the queen. Workarounds will avoid a storm when they're searching randomly. However, when they're carrying food, they'll just kind of walk straight into it if it's in their way. And it will kill the ant. The location on the weather should be displaying the details and area details of the simulation world to its position tracking. We also want to display a message. This is kind of weirdly, annoyingly in another bit, but we want to display a message of ants or pheromones destroyed. Now, this is like my 6th time trying this task, because every time there's a new bug I've not foreseen, but I think I can get it right this time. That's what I said the last 5 times, but never mind. Right, let's take it, copy it, paste it, rename it as Z10, and open it there. Make sure I close the original so I don't accidentally change it. Right, so shut this off. Let's have this to the side real quick. In here, we want, well, a new weather class, not storm, fair enough. So let's inherit entity. So let's go and look for entity. We're here. We're going to check it right underneath class weather inherits entity. Now, what do we want to inherit from this? Definitely the constructor, because we really don't need more than the supers, except what we want to keep track of the age of certain entities, like the one that do age, you want stages. So, like the last time, there's stuff that is in the end class that I'm just copying over, but really you would have a separate level of abstraction to keep track of intermediary entities. So we just initialize it like we do any other entity and set the stages to 0. Now, the main thing is going to be an advanced stage. So in the weather class, let's remove the ant and pheromones. Let's just put the definition self-nest pheromones. Look, it's already prototyped, right? We already have the signature in the entity class, which is here. But at the moment, it does nothing, right? So I don't really want to call this. But it's useful. I'll take nest, ants, and pheromones, which I'll take from the simulation class. What we are going to want to do, we are going to want to remove pheromones, remove ants, or the other way around maybe, and then actually, age, and if old enough, die. And this is going to be my last bit, so I'm just doing self underscore stages plus equal 1, and then if self dot underscore stages is larger or equal to, I want to say weight. So I'm going to initialize it at 0, it's going to do its stuff, and then at the end it's now going to be 1 old, and then 2 old, and then 3 old. So there's 0, 1, 2, and if we end up on 3, so if it's equal, I mean, let's make it larger or equal. It should never get larger, but just the principle is if we go above or equate 3, we want to return true, and else, or we don't even have to run else because there's a return there, but else return false. So this means we can't die. To die, we need to remove ourselves. We need to remove the reference to the instance of this object. This is how for ants, we take them out of the underscore ants attribute, list attribute of the simulation instance. But this will return true if this was the last stage of weather. Cool. So I'm going to get back to this in a minute, but let's just do the basic stuff. So in, just don't want to have this here, it's just too, right. So in here, in my simulation class, right, as I initialize this, I will want self dot underscore storm is equal to a weather event. No, not yet, actually. We start with no storm. That's the important thing. But I know that my reference to my weather object are going to be in that underscore storm attribute, which means I can now, there's like a get details, yes, get details, get area details. Like we did last time, this builds a string with all of the details of what's in the cell. So in here, we're going to say if there is a, is it storm I've called it? Yeah, if we have a storm going on, and if self._storm in same location as, and they call it temp cell. Remember, in same location, that's super useful method in the entity class to tell you whether two entities are in the same location. And if that's the case, we will add to the detail string plus equal storm. And now that I have this little snippet of code, I'm also going to add it and get area details. So same deal after we've built, put it in the right place though, right? So it's after the, well, maybe we get food in this cell, but before, of course, the line break that marks the, that line, because when we render the simulation, we render the 2D grid as a 1D column. So we've done a bit of, we've done this definitely. We've not done that yet. What we have done is this, so that's helpful. That's kind of out of our way. Now, advanced stage, so it has a 75% chance of WorkerAnt at any stage. Let's have a look. This is in, not details, def advance. Right, so this is a lot of the meat of the action of the simulation happens here. We repeat this however many stages we're incrementing. First, we're deleting pheromones. It's the old delete from the list trick, so you need a separate list of what you can delete, then iterate over that list to remove them. Then we iterate over the ants, and then we do the nest. So I need to think a little bit here. I suppose we could put it at the top. Not feeling lucky. So, if there is a storm happening, no, self. If there is a storm, we're gonna self._storm.advance stage, to which we're gonna pass, like in the, yeah, right, like when we call advanced stage on the ants, we pass this, so we're just going to keep, we have the same function signature, so we're just going to pass it again. We're not going to really use this variable, but I'm keeping the, kept the signature the same. And that's all we're doing here, because the rest is going to happen in advanced stage, else. Oh, so if you want to look at examples of, yeah, that's a good, no, that's not necessarily the right example of random draw. There is a, yeah, right? So this is, if you want something has a, that's a 50% chance of happening, or this is a 2% chance of happening for spawning a queen, you draw a random number between 0 and 99, and then you check if the number is strictly lower than the thing you're trying to check against. So in here, advanced stage, yes, I was here. So otherwise, we draw a random number. Randant, between 0 and 99. And if random number is strictly lower than 75, then we spawn a storm. Well, we spawn a weather, in our storm. And whether, like any entity, takes the row and column, so this is in self underscore. No, sorry, this is random, right? A random place on the board, which is like we do random nest. So again, if you search for randint, you'll find it. Right, this is, yeah, kind of like row column from 1, because we index from 1 to the number of rows, or 1 to number of column. So random.randint brackets 1 to self._number of rows, and then the second one is random.randint 1 self._number of columns. Cracking. So now we have a new storm. What I've missed here is actually we need to figure out if there is a storm on and we advance a stage and we're at the last stage, we want to, so we put there in an if, and if that is true, if that returns true, we will get back to self_storm equals none. Now, objects exist or not in the simulation, depending on whether the simulation instance or the instance of the simulation class is holding a reference to an instance of the object. So the moment we dereference the weather instance, it ceases existing. This is how you create and delete them. Now, advanced stage is going to need to do a little bit of work here. So let's find it. It's not this one, not this one, not this one. It is not this one, but it is this one. Cool. So remove pheromones, remove ants. Same as before. Let's do the ants first. So ants to remove. Start with the empty list, and then for a in ants, then if a, we could start do a in same, well, let's do self. Yeah, in same location, because it knows that self is an entity, it doesn't know that a is an entity. If it's in same location as a, then we add the ant to the list of ants to remove. Append a. And then here, once we've finished iterating, if there are ants to remove, then we will remove them, meaning we go ants.remove. The ants is the big list of ants that pass from the simulation. We move ants remove a. And we want to, no, actually not ants remove a. For a in ants to remove, for each of the ones we've selected for removal, we need to remove it. And once we have done, maybe with 4 space indent, I guess. And once we've done this, we also want to print this message, fstring storm at self_row column removed length of ants to remove. Oops, ants. Let's put a capital here for reasons that will become clear just now, because for the pheromones, I'm going to take all of this and then select ants, do Control-D, 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 and simply replace this by pheromones. Now, of course, for consistency, I will also take the A's, actually all the A's, so that's 1, 2, 3, 4, 5, and replace that by a P. Cool. That should do most of the job. The one problem we now have is trying to make sure the worker ants avoid the storm when it's going on. And that's kind of a difficult bit, I'm not going to lie. Have I forgotten something here? Hopefully that's good. Okay, so in the simulation's advanced stage, which again really is where the magic happens, this is our new bit for the storms. We deal with the pheromones, so that's the deletion of pheromones because they deprecate. That's not the right word. They, rot away. They attenuate. There's a word for this. There's a decay rate of pheromones. And then for each of the ants, we advance the stage. Advance the stage for the ants just like ticks over their age. The main thing, this is whether it's at the nest, do we pass it to the nest? If it's not carrying food, but there's food in the cell, then it picks them up, and it keeps picking them up, etc. But the main, right, whatever here, if it's carrying some food, it puts pheromone in the cell, and this is the movement of the ant. So the movement of the ant only takes the list of neighbors of the cell where the ant is, as well as if there are pheromones around, the index of the neighbor with the strongest pheromones. Now, this list of neighbors is a list of indices, and this index is an index, and that is an index in the self._grid, right, of the simulation. So this is all of the cells the simulation knows about are set up in a linear array, although you can get it via the row and column. There's a calculation function here, and then those are indices in self._grid. Now, if we have a look at choose cell to move to for the ants, look, pass, right. This is, if the ant is carrying food, it's going to just go in rows and columns to get back to the nest, which means it's going to walk straight into the storm if it's here. This is what we want, that's good. If it doesn't have an index of neighbor as strong as pheromone, it's going to choose a random neighbor from the list of neighbors. If it has an index of neighbors as strong as pheromone, it's going to use that one in the list of neighbors. Now, the ant does not know there is a storm on, so it is the job of we're not going to change anything here because we can't, because this code does not know that there's a storm, let alone where the storm is. The only bit of the code that knows this is the simulation class, so it's in here in our advanced stage that I was there a minute ago, right? That before calling this, we'll want to actually change what we pass here, particularly the indices of neighbors, so that we consider the cell in which the storm is to not exist, right? If we do -1, it means, oh, this is not a valid cell, probably because most of the time it's the edge of the map. So, in here, I'm not sounding confident, but we will see. If self underscore storm, so if there is a storm, actually, let's take this and replace it by list of neighbors, which I'm going to get, sorry, and list of neighbors is equal to that. And is that enough? I think that should be it, right? And so this list of neighbors, which again is a list of indices in the grid array, may contain the storm. How do we find out? So for n in list of neighbors, and that's if n dot is in same location. No, because that's a cell. So n is going to be an index in the self grid. So if self underscore grid at index n, that's a cell in same location as self dot underscore storm. That's how I know if it's in the same location. And what I want to do is remove it from the list of neighbors. But because I'm iterating over the actual elements, I can't do this. So quick change here. We're going to iterate like in GCSE. So I'm replacing this by an explicit I iterator, wrapping this into brackets, and I'm going to take the length of this, and actually I'm going to do a range on the length of this. Now I've got I, so n is now, instead of n, it's list of neighbors at index I, and so if it is in the same location, list of neighbors at index I becomes equal to -1. And because this is what we're going to pass in here, it's not even going to consider this as a valid neighbor to move to. Now, it shouldn't be possible that this forbidden cell has the strongest pheromone, right? Because we have just above, we've run all the code that will, in the advanced stage of the storm, which is actually above everything else, right? We will remove the pheromones. But just in case, I mean, we know this is a possible bug. I'm not quite sure. It depends where you actually put the call to the update. But anyway, let's have a look at. So testing it, it's literally 1 and press 4 until, and verify what you've got. So let's see. Question mark. Oh, cracking. Submission number 1 and then 4, 4, 4. Oh, sorry. I need the, whatever. If I want to be doing this, I actually want, when I create a storm, I might want a little message, so at least I know that I need to maybe check, right, and see where this new storm is. Well, maybe I won't. Let's not accidentally delete a line, that would end poorly. So here we are going to print, it's an F string because I'm going to use the coordinates, and it's storm at curly's self dot underscore storm dot get row, comma, self dot underscore storm, not this one, get column. Cool. Right, so if I've got this, it should work a wee bit better. Submission number 1. Advanced 1 stage. Yeah, we get a storm. Let's check that it is actually being displayed. Right, so that's the storm doesn't touch the food. It was the bird, just the smell of the food, really. So now the storm should be dead because there's been three ticks and it's not there anymore. Yeah, I'm happy about this. So let's keep going. There's a storm now at 5.5. Well, that's the corner. Not very interesting. Sometimes the storm doesn't kill any ants before the ants all die of starvation, which is a bit of a problem. Okay, so all of the ants have died. That's unfortunate. But that's not to say the code doesn't work. It's the problem is that this is why you will never get a task like this unless they maybe tell you to test it with a specific seed where you can actually control what the behavior is going to be, because it's always repeats in the same way. So I've got a 2-5, again not, well, maybe the nest is at 2-4. Yeah, so it's on the food and stuff, maybe that's gonna, aha, yes, it's removing pheromones, cool, yeah, we get a win here. Not sure how those pheromones could have been laid without the ants being killed. Right? Is it the same storm at 3-3? Yeah. Oh no, I had 5 ants back then, and I know it's not the same one. All right, well, so I'm gonna keep advancing. Okay, I'm starting to have doubt that my things were. I mean, it's removing pheromones. Is it removing ants? Is this done? Is it working? How can we know? Well, there's no more. Is there no more ants on the? Yeah, there's no more ants in the simulation. They all kind of end up dying. Well, that's helpful. Oh, gosh darn it! Let's do it again. Oh, the storm is bang on the nest. Now, surely that should kill some ants. Yes, right. Look, I think we've seen some ants being removed. We've seen some ants, you know, we can't prove that they avoid it in random motion, but actually walk straight into it when they're bringing back food, unless we see obviously the storm like first being created and then removing some ants. But like, you know, calculating this and getting that right for testing is very dependent on the random draw. So let's call that tested and working. A bit debatable, but you know, we can now have a look at the diff. The diff. Is that working? Yeah, cool. Oh, except now I'm not mirrored. So no, it's not that way. Yeah, the diff is here. Cool, right. So the diff, fairly simple. We have this new storm, I mean in order, right? When you select the simulation, we set a new storm attribute, but it contains nothing. That is to say, and then we render, if there is a storm, we render it in both of the get details and get array details methods. Then, if there is a storm, we advance a stage, and if the advanced stage returns true, the storm has aged out, and we dereferenced it by saying by setting the pointer to none. However, if the pointer is none and there is not a storm there, we draw a random number and we've got a 75% chance of a new storm being created, and we print a little message, so it's helpful to know what's going on in the simulation. Now here, this is to avoid the ants walking right into the storm. Instead of just passing just the indices of the neighbors, I need to put it into a variable and then iterate over it. If there is a storm, I iterate over that variable. Sorry, it's that way. And if, so yeah, I iterate over that list of neighbors, and if any of those neighbors are in the same location as the storm, I actually set the value to -1 to say it's not a valid cell. And finally, the big action here is this new object, new class that inherits entity. The init is just the same, the super, to give it row and column, but it counts stages because it ages stages a few ages, so we need to initialize it at 0. And then the advanced stage has got removal code for both ants and pheromone. By now you know the pattern, right? Like the ant culling did that, the bird did that, like plenty, you know, every time you need to remove something, you need to dereference it. So if it's just self._bird or self._storm, you set that to none. But if it is a list, you need to iterate over the list, figure out on all of the items you want removed, and then in a separate bit, iterates over the ones you want to remove, and then remove them from the list. So a bit mouthy, but like once you get the pattern, you just like, yeah, you go ahead and rip it off. And in fact, you will find this in the code, right? Like, so none of the, usually, very rarely is like a line of code you need to type not present in some form already in the code. So the random number draw, that's in there, the kind of removers from list, that's in there, the way the ants move, etc. And then finally, we have the aging code, so we increment the stages, or the ages, the stages for the age. And then if that's larger or equal to true, that was the last round of removal of the storm, and then we return true, so that the advanced stage in the simulation class sets it back to none. And that, folks, is your task number 10. So see you very soon. I am streaming this afternoon. I also need to put a link in the description because there's an online class. So if you're interested in being on a call with me, streamed live to YouTube, where we work on Ant Simulator together, register your interest in the link. See you soon.